Hi, my name's Ian Jenner from a company called Autoclave and Industrial Controls, an engineering firm based in the south of the UK, specialising in maintenance, calibration and control of process control systems, primarily in the composite industry. So I'll talk briefly about some misunderstandings about how thermocouples work and how this can introduce errors into measurements. This time it's been suggested that calibrating an autoclave or oven by simulation from the internal sockets provides some assurance that the permanently installed part of the thermocouple cable is not a source of error. Now, if this was correct, then any defect in that thermocouple cable would be detected during the calibration. So we can see here we have just a normal process calibrator and our field test instrument chart recorder, and they're both set up to read Type N calibration, and they're connected together with Type N thermocouple cable, and as you'd expect we've got a pretty accurate reading in there. So what I'm going to do is I'm going to change the Type N cable for Type K cable, which is clearly not correct. Now, the voltage generated by Type K thermocouples at 180 degrees C, as we've got here, ought to be equivalent to 240 degrees Celsius. But in fact we're reading almost exactly the same, 179.54. And this is because the voltage, the signal generated in the thermocouple cable, is generated where there is an area of temperature gradient. So anywhere that experiences a temperature gradient will experience a voltage. Simply passing a voltage down it from our process calibrator makes no difference to the character of the cable. In this case, the cable is just passing through around the back of the instrument here, and so there's very little temperature gradient along the back, so there's almost no scope for the incorrect cable to have an impact. Just change it again for Type T. Type T, the voltage generated by Type T at 180 degrees C ought to be equivalent to about 280 degrees in Type N. And again you see negligible difference. Well, I'll put some heat into it, I've been handling it, but again 179.5, half a degree's difference, not 100 degrees difference you would expect. And given a bit more time to stabilise, that comes back to about the right point. And just to really drive the point, instead of using thermocouple cable at all, just use a piece of copper wire. Plug that in there. It's obviously a copper wire. Shouldn't make any difference at all, but because the temperature gradient is 0 along the cable, the copper wire introduces almost no error into the system. So all of the signal, say for 1 degree perhaps, that's significant in this calibration is what comes out of the process calibrator and is measured at the junctions at the back of the instrument under test. And the cable in the middle of it, if it has even a very significant error, like it's completely the wrong kind of cable, this won't be shown up with this type of calibration. Of course, it's very unlikely in practice that you'd have the wrong type of cable installed in the machine. What's more likely to happen is that the cable that's permanently installed in the machine ages and drifts from contamination and normal thermal cycling, which affects all base metal thermocouples to one degree or another. And over a period of time, you diligently calibrate the autoclave by plugging into the sockets and measuring it at the instruments, and every time you do it, you get the right answer. But when you actually heat the machine up and operate it, the temperature gradient is now, there is now a temperature gradient in that part of the cable, and it becomes a significant source of error. So, how can we calibrate this thermocouple cable and assure ourselves that it's not introducing sources of error in our measurement and control? Well, ASTM, British and other thermocouple standards all state that standard techniques for calibrating thermocouple cable are only applicable when the cable is new. If you want to remove the cable to calibrate it, you have to be very confident that you can exactly recreate the temperature gradients that the cable will experience in practice. Otherwise, the inhomogeneity in one part of the cable that experiences that introduce an error in practice may not introduce an error during your calibration. The alternative method, which is recommended, is to carry out an in situ calibration where you actually take the machine up to its operating condition with a reference standard next to it, completely independent, and compare the readings using that method. Failing that, the only alternative is to replace the cable. On some machines that may be the most cost-effective way of doing it, but for many autoclaves and ovens with dozens and dozens of thermocouple cables installed, the cost will be prohibitive. But an in situ calibration, provided you know that all of the batches of thermocouples are the same and they've seen the same cycling, ought to provide good assurance that your measurements are indeed accurate.